right, let's take a look at Chapter 5, Numeration Systems. 5.1 talks about the evolution of numeration systems. Our goal is to represent numbers and compute in the Egyptian system, calculate in Roman numeration system, make conversions in the Chinese numeration system. Numbers and numerals. A number tells us how many objects we are counting. A numeral is a symbol that represents a number. The number 10 means the same in all numeration systems, but the numeral for 10 varies greatly. Mouse is broken. The Egyptian numeration system, a simple grouping system. Numerals are formed by combining the symbols that represent various powers of 10. So we have a stroke that represents a 1. We have a heel bone that represents a 10. We have a scroll that represents a 100. A lotus flower that represents 1,000. A pointing finger that represents 10,000. A fish or a tadpole that represents 100,000. And an astonished person represents 1,000,000. The value of the number is the sum of the values of the numerals. For example, the number 325 is represented as 3 scrolls, 2 heel bones, and 5 strokes, or 3 of the 100s, 2 of the 10s, and 5 of the 1s. The order of the symbols is not important. We could also write 325 as 2 strokes, 2 scrolls, a heel bone, another scroll, another heel bone, and the other 3 strokes. Because we still have our 3 scrolls, our 2 heel bones, and our 5 strokes, our 3 100s, our 2 10s, and our 5 1s. Convert 3 lotus flowers, 4 scrolls, 2 heel bones, and 2 4 5 strokes to Hindu Arabic notation. Hindu Arabic notation is what we call the base 10 system we've been using in our own system. Solution. We have 3,400s, 2 10s, and 5 1s. So the Egyptian numeral represents 3,000 plus 400 plus 20 plus 5, which is 3,425. Add 3 scrolls, 2 4 6 7 heel bones, 2 strokes, and 2 scrolls, 5 heel bones, and 3 strokes. Solution is just to stack them like we do in our traditional algorithm and combine like symbols. So we combine all the scrolls together, all the heel bones together, all the ones together, all the strokes. We rewrite the 10 heel bones as 1 scroll, just like in our own base 10 system, we regroup. So we're going to regroup 10 heel bones as 1 scroll, or 7 strokes, 2 heel bones, and 5 strokes. 6 scrolls, 2 heel bones, 5 strokes. An example of adding and subtracting in the Egyptian system. If we subtract 2 4 6 heel bones and 2 strokes from 2 scrolls, 3 heel bones, and 4 strokes, then what do we have? We set our solution up stacked just like we do in the traditional borrowing algorithm for base 10 numerals. This time though, we're just looking at the symbols. So we can't take the 2, 4, 6 heel bones symbolically away from the other amount. So we have to rewrite one of the scrolls as 10 heel bones. And again, we do this in our base 10 system. This is called borrowing, right? We borrow a unit from next door and convert it into what we need. So here we have changed one of the scrolls into 10 heel bones. We've borrowed a scroll and turned it into heel bones. And now symbolically, we can just take away a heel bone for heel bone and a stroke for a stroke. So now once we've removed these symbols, we're left with one scroll, 7 heel bones, and 2 strokes. The Egyptian numeration system also had a method of multiplication. Basis. Any positive integer can be written as the sum of powers of 2. So this is also something we do with binary. 2 to the power 0 is 1. 2 to the power 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 6 is 64. So 19, for example, is 1 plus 2 plus 16. 81 is 1 plus 16 plus 64, using the highest value of power 2s we can. So the way they would then double is they could multiply 19 times 2 and they just write the next power of 2 symbol down. Computing area using the Egyptian method of doubling. A craftsman is restoring a rectangular wall of the temple of Queen Hatshepsut, the 5th pharaoh of the 18th dynasty of ancient Egypt, with tiles. If the wall measures 13 feet by 21 feet, use the Egyptian method of doubling to determine how many square feet must be covered. Solution. We first write 13 as 1 plus 4 plus 8. To find the area, we will calculate 13 times 21 as follows. Turn the 13 into 1 plus 4 plus 8, and then multiply using the distributive property that form of 13 times 21, so that we have 21 times 1 plus 21 times 4 plus 21 times 8. We find the products by repeatedly doubling 21 as shown in the table. So 21 doubled is 42, doubled is 84, doubled is 168, doubled is 336. And we need the products for 1, 4, and 8, because we have 1 times 21, 4 times 21, and 8 times 21. When we find this in the table, that is 21 plus 84 plus 168, which yields 273. Craftsman must use 273 square feet of tile for the temple wall. The Roman numeration system. The Romans used letters of the alphabet as numerals. For example, the 1 was the I, the 5 was the V, 10 is an X, 50 L, 100 C, 500 D, 1000 M. Notice these are capital letters. Example, a simple conversion of a Roman numeral to Hindu Arabic notation. Convert DCLXXVIII to Hindu Arabic notation. The solution. It's important to recognize that in DCLXXVIII, a numeral with a smaller value never occurs to the left of a numeral with a larger value. So as you read from left to right, the numeral values decrease. So we have 500 plus 100 plus 50 plus 10 plus 10 plus 5 plus 1 plus 1 plus 1, which equals 678. If the value of the numeral is ever less than the value of the numeral to its right, so if you're reading from left to right and you have a small numeral that then goes to a bigger numeral, then the value of the left numeral is subtracted from the value of the numeral to its right. For example, IV, the I is less than the V. So this symbol represents 5 minus 1, which is 4. IX represents 10 minus 1. XL, X is less than L, so we're going to take the X away from L. We take 10 away from 50, giving us 40. And CM, for example, C is 100, M is 1,000. We take 100 away from 1,000 to get 900. There are two restrictions on this subtraction principle. We can only subtract the numerals I, X, C, and M. For example, we cannot use VL to represent 45. So only use your base 10 numerals to subtract. We can only subtract numerals from the next two higher numerals. For instance, we can only subtract I from V and X. Therefore, we cannot use IC to represent 99. You can use I to subtract until you hit the next base 10 numeral, which is the X, the 10. Then you start being able to subtract with your X, but you no longer can subtract with your I. So it only can subtract through the next two higher numerals. Translating between Roman numerals and Hindu Arabic notation. Convert MCM XL III to Hindu Arabic notation. Solution. The diagram shows how to interpret this numeral. Remember, every time we see a smaller number to the left of a larger numeral, we must subtract. So we have M, but then we have CM, XL, III. So M is a standalone at 1,000. We then go down to 100 and back up to 1,000. So that means we need to subtract the 100 from the 1,000. So we have 1,000 plus 900. And then our next grouping goes down to a 10, but back up to a 50, which means we subtract the 10 from the 50 and get ourselves a 40 and move on to the next set of numerals, which is III, giving ourselves a 3. So as you're reading from left to right, if it ever dips down and then goes back up, that's an indication you need to subtract. You subtract from the numeral in front. So we read from left to right. So you subtract from the numeral to the right, not from the numeral to the left. So sometimes the mistake students make is they subtract from both the front and the back, or both the right and the left. But that's not correct. You should always only subtract from the next numeral, which is the right numeral reading from left to right. 1,000 plus 900 plus 40 plus 3 is 1943. Write 492 in Roman numerals. Solution. 400 could be written as CD. Take 100 away from 500. 90 could be written as XC. Take 10 away from 100. And 2 could be written as 2 individual I's. Putting this together, 492 is CD, XC, II in Roman numerals. The Roman system. A bar above a symbol means to multiply the value by 1,000, and bracketing a symbol with two vertical bars means multiply the value by 100. And now let's look at the Chinese system. This Chinese system uses multiples of powers of 10, such as 10, 100, 1,000. The system is a multiplicative system. Numerals are formed by writing products of integers between 1 and 9 and powers of 10. Express these 5 symbols in Hindu-Arabic notation. Solution. The one that kind of looks like an H is a 9, and then the one that kind of looks like a T is 100. So we have 9 times 100. And then we have another coefficient of 4, looking like a window, maybe with a little curtain on the top, times a lowercase looking t, right? So the lowercase t is the 10, the base 10 system. So we have a coefficient times a base 10 number, coefficient times a base 10 number, coefficient, no need for a base 10 number because the base 10 number here is the unit, or the 1. So we have 9 times 100 times plus, 9 times 100 plus 4 times 10 plus 2 for 942. Write 3,542 in Chinese notation. So we would have 3 bars for our coefficient of 3 times 1,000. So it looks like a cross with a top, right? Or a T, a capital T combined with the lowercase t. Now we need our 5 for our coefficient and 100 for our base 10 number. So 5 100s and 4 10s. So we have our coefficient of 4 and our base 10 notation for 10 and 2 units for a total combined symbolism of these 7 symbols, reading from left to right.